your department. So thank you once again, and I think with all our experts interactions and their rich experiences, this session will be enriched with some sort of a definite take-home message for the potential PIs on this energy storage solution. And whatever may be suggestions and queries will be there, then we can also take it further follow up with our experts. And we hope that by this way, we have a good research initiative on energy storage solution sectors. And we are also inviting that academicians as well as the industry sectors also in the next session also, so that we have to understand that what exactly the need of the hour, need of the industry, and accordingly we can prepare our guidelines so that it would be helping each other. So with this word, I welcome all the experts members, and I welcome also all the potential PIs, and I hope that this session will be very enriching and very much uh, educative for all of you, and we can get a good proposal, less chance of rejection, and great chance of saving our time and effort, so that we in a definite time period we can our TSC will be getting, yeah, the recommendation, and the department will be happy to fund it. So thank you so much, and with this word I request our principal scientific officer Dr. Poonam Bhargav to introduce our faculties, and we can start the session.
Thank you, sir. As sir said, so this entire session will bring out new solutions and global solutions, new ideas can be submitted under various schemes. So, with great pleasure, I would like to now invite Dr. Biswajit Roy, Director General Journey, who is an institute with the ability and create successful complex situations. Dr. Roy has over 38 years of with the leading oil and gas giants of Government of India, namely Oil India Limited and Limited. Before joining Journey, he worked as advisor to the chairman and managing director, Daikin Air Conditioning India Private Limited. He is a graduate from IIT Roorkee in chemical engineering and has done management graduate under Premium National Management Program from Management Development Institute, Gurgaon. He has been a recipient of international and national awards for distinguished work of Oil India and Indian Oil Corporation Limited on trainings, CSR, and sustainability. He has several papers, publications, energy, oil and gas, human resource development, sustainability, and CSR. Dr. Roy has been associated in the past with industry forums, namely International Study Network, Indian Society for Training and Development, and CIM. With this initiative, sir, I again thank you for giving us time, your valuable time, and we look forward to your talk on.
Hand looks like. अपने आप problem कुछ? Are you able to hear me?
Yes, sir.
Yes.
We are able to hear you. You can also get your video on.
Yeah, I will get my video on. For a
Yes.
little while, I think the screen froze at my end, so therefore there was a little difficulty at my side. Let me just get my video on.
Yes,
And
sir. We can.
let me also get the presentation now. So thank you, Dr. Sahu. Thank you, all the colleagues from GUJCOST. I will soon come and visit GUJCOST along with my other colleagues.
Yes, sir.
As you have rightly said, I actually come from oil and gas background, so I am no expert as far as battery energy storage technology is concerned. But I will definitely give a flavor to the participants here today as to why it is important and which are some of those areas where a little research is required in the context of India. Everybody is talking of lithium-ion batteries, but lithium is not available in the country. So therefore, from the energy security point of view, there are alternatives where people need to work. And that will be the focus of my presentation. And There are enough opportunities available as we move forward. So before I actually, is the screen can be seen?
Yes, yes, sir. Yes, sir, we can.
Okay. So I will
Yes.
present a few slides initially about Germany. A lot of people may not be aware of Germany. Some may know, some may not know. So briefly about Germany, and then I will come to the main presentation. So Germany is an autonomous body under the government of Gujarat. It's been promoted by GSPC, which is a state PSU. We are a society and a trust, not for profit, recognized by Government of India as scientific and industrial research organization, and everything else that is written here on the screen. We are ISO certified, and we are the parent body of PDEU, Pandit Deendayal Energy University. We have NAPL certified labs also. This is the organogram. This is where you can see me. We have 5 verticals: new technology management, renewable energy, environment management, petroleum research, and petroleum management, which is for basically for seismic data interpretation. These are some of the record of our academic R&D and consultancy records. So this kind of work we have been undertaking in the past. I'm not going through all the slides, but one can actually see some doctorates have been completed. Some are under work, some are under completion. There are publications, there are reports. We actually work as a advisor to the government for some of the policies that the government requires. Those are the kind of things that we do. We do a lot of consultancy assignments in various domains. So we cater to government, public, private, researchers, professionals, students, everybody else, and these are the kind of activities which are there on the right-hand side. Advisory work that we undertake, project management consultancy, third-party inspections, fundamental and applied research, training, higher education, etc., etc. These are some of the success stories of Germany. The first rooftop program, megawatt scale solar projects, first canal top in the world. These are kind of things. This microgrid solar we have undertaken in CMPDI Ranchi. So these are the kind of things that we do just to get a flavor of what Germany does. If there are people who would like to collaborate with Germany, they can understand, they can get a feel of what Germany does. This, in fact, is one of our flagship projects, the entire city of Modera. And this was inaugurated by Honorable Prime Minister. It's been solarized completely, and Germany was the project management consultant. Some of the technical details are here. 6 megawatt of ground-mounted solar plant, 15 megawatt hours of lithium-based battery energy storage, and EV charging infra. There are 1,500 to 1,700 homes, and the entire Sun Temple. On a 24/7 basis, it is lit through the power requirements are met through the solar energy. We provide these kinds of policy support. We have provided, and we are in the process of providing also. We are doing something in the area of biogas as well, bioenergy. We have actually done the solar technology assessment. How much of rooftop, how much of solar energy can be generated in Gift City. We have prepared the solar master plan. We are a center of excellence by the Skill Council for Green Jobs. These are some of the major clients in the international level, in the central state PSUs, in the government institutions and private sector. We are now in the process of setting up of our own building. We are right now operating from a building within PDU campus, but this is where our new building will come up. These are some glimpses of what we will have. We will have electrical research and testing laboratory. We will have a battery testing laboratory. We will also have soon a electrical vehicle testing facility. And in brief, in a nutshell, this is what Germany's contribution to the nation is. Ultimately, we want to be a key player in realizing its ambition, our country's ambition of becoming a net zero by 2070. Now let's move on to this is as far as what Germany does. What is the profile of Germany? Let's come to why are we talking of BESS? It's important because there's a target of 500 gigawatt renewable energy by 2030 by government of India. We all know about it. What we also know is that India's emissions in 2023 were approximately 2.8 gigatons. And we also know that in Glasgow, Prime Minister had committed a reduction of projected emissions by 1 billion tons by 2030. Now, how will this be achieved? The emissions are taking place from majorly from 2, 3, 4 areas. One of them is transport sector. The other is the industrial sector. The third is the agricultural sector. And the fourth is the building construction sector. Now, transport contributes about 30%. If we can actually handle the transport sector, we can try and reduce the 30% emissions that are taking place. And we are doing all of it because we are actually in the midst of a crisis. And to be able to attain these targets that are written here, India needs a significant amount of grid storage and proliferation of electric vehicles. Why grid storage? Because the distributed model of renewable energy which is intermittent in nature, will actually require storage at a point in time from the stability point of view of the grid. So therefore, there is enormous potential for large scale battery manufacturing in the country. We are very minuscule as far as the world is concerned today. And this will also help in creating jobs and capturing economic value. Currently, India has negligible presence, as I said, in the manufacturing of ACC, advanced cell technologies. We said that 30% of new vehicle sales to be electric by 2030. It's a stated policy of the government. So here is an opportunity, a powerful opportunity to emerge as a global leader in the new mobility solutions and battery manufacturing. Some of the companies are actually taking action also, but at the world level, it is a very small kind of action that we have taken. Now, all of these things together, and India is a booming economy, they position India in a very unique way to deploy EVs at scale, large numbers, and to be able to leapfrog the, in the petroleum sector, we have BS4, BS5, BS6, and then we are gradually moving on. We can leapfrog that, and we can immediately come to EVs, which will help in 2, 3 ways. One, emission reduction. Two, our reduction on import dependence. The import bill of the country ranges between 100 billion to 150 billion every year. So that money can be saved. And it will also, when the numbers will become large, it will also drive down the costs of batteries through economies of scale, even faster than the current projections anticipate. I will show you some projections also. The international market is expected to exceed USD 150 billion annually by 2030. And there are studies from Niti Aayog suggesting that India could obtain a major share of up to 13%. So all the entrepreneurs who are sitting here, all the researchers who are sitting here, all those who are from the manufacturing sector, you can actually see that there's a huge, huge opportunity that's available for us to grab. So there are two scenarios which have been developed by Niti Aayog. One is the accelerated scenario and the other one is the conservative scenario. Under the accelerated scenario, the battery demand is expected to grow to 260 gigawatt hours by 2030, which means 26 gigafactories. Generally, the definition of a gigafactory is 5 gigawatt hour per year, but we have assumed that 10 gigawatt per hour factories will be the size, and therefore we will require in the accelerated scenario 26 gigafactories. In the conservative scenario, it will be scaled down to 10 gigafactories. So nevertheless, there is a huge opportunity available. And realizing this, Government of India had also announced a productivity linked incentive scheme to accelerate the growth of this sector for all those people who would like to participate. इसको जरा full screen करो. Now, the issue is why just this full screen presentation. Now, the issue is why now? Because we are all in the midst of a climate crisis, and there is a global consensus that we need to do something so that we are able to limit ourselves to 1.5 degrees centigrade. So there is a global climate action that is taking place, and there is a need for higher share of renewable energy in the energy basket. So as more and more solar, more and more wind, more and more other forms of alternative energies actually start coming in, we will have to bring them together in the grid. So therefore, we need to have a higher share, and that cannot be done without having battery energy storage. This will also provide the country with energy securities. It's also important because, as per one of the studies, 22 Indian cities are figuring in the top 20, top 30 most polluted cities in the world. And a major factor of pollution emission is the transport sector. There are other sectors also, but transport is also one of the major ones. The country has electric vehicle ambition. This will also help in industrial development and indigenization. And if we get into larger share of, increasing number of production, then the battery costs will also fall. Today it's expensive. The accelerated scenario, and these are all taken from Niti Aayog report. In the accelerated scenario, 2020 EV share will be 21%. EV share is 21%, and on the right hand side is the market size. So by 2030, it is anticipated that the market size will be of 16 billion, and we are talking of India. We are not talking of world at the moment. And these are the sectors which will actually be contributing to it: passenger EVs, commercial EVs, etc., all that is written here. And you can find that stationary storage of grid scale, that will be a major share by 2030. So there is a lot of potential and there is a lot of research that is required to be undertaken. This is what is the projection. EVs will ultimately have a share of 40%. In the conservative scenario, even there, stationary storage will have a major share, though it will be around, the market size will be around $6 billion and gigawatt per year will be somewhere around 100 plus. But nevertheless, there is a need. The actual situation will be somewhere in between the conservative scenario and the bullish scenario. What is the international demand scenario? Let's also look at what the international situation is. The annual demand, the global demand for lithium-ion batteries is expected to reach more than 2.8 terawatt hours annually, and we were talking only in terms of gigawatt by 2030, with a vast majority of that demand serving electric transportation. So it's a fact, world over, there is a shift, and that we need to get into battery energy storage system is soon going to be a reality. While nothing significant has yet happened, but I will show you in one of the slides that people are taking action, and we are somewhere in the region of 4.6 gigawatt hours kind of storage systems which are likely to come up in India very soon. Investment in ESS, energy storage systems, globally it reached 6.3 billion in 2020, and by 2030 it is expected to be 30 billion, and Asia Pacific will have a major share, and we will be a dominant player in Asia Pacific. At least India has that ambition, the government has that ambition. Lithium-ion battery, today what the situation is, in 2020, China was 78%. By 2025, it is expected China will be 65%. And you will find in 2020, there were no share of the others, which is coming in share of others as 6%. India will be somewhere within that 6%. How much will it be? It will be less than 1%. The numbers suggest that. But it is important that we now take the required actions. And that is why this conference is so appropriate in terms of time. Dr. Sahu has organized it so very well now that all those people who want to get into this, they can actually have an understanding how big the pie is and why it is important for us to now get into it. ESS capacity developed in India announced is 1.2 gigawatt hours, different companies. Tenders have been issued for 3.3 gigawatt hours. Under construction is a small number, 0.085 gigawatt hours. By combining all of them together, we are expecting 4.6 gigawatt hours. We need somewhere in the numbers that I have shown you in the previous slides, large numbers. But nevertheless, a beginning has been made. These batteries will also have a second life. They will also have a secondary use. And this is how it will look like in the conservative as well as in the accelerated scenario. The reality will be somewhere in between conservative and accelerated, but nevertheless, it will be somewhere around 10 gigawatt to 12 gigawatts per hour in the second life. So those who get in now will also have the opportunity to get into its second life use. So it's a very attractive sector now. So various options in ESS. What are the various options? Advances in battery technologies, including advanced lithium-ion cathodes and anodes, lithium-sulfur batteries, etc., etc. There are all kinds of batteries that are being talked about now, flow batteries. They could be crucial in advancing the next stage of energy transition. Today it is expensive, but with research and with large numbers coming in, the scale coming in, it will become affordable. And they should be encouraged and supported in the market. These innovations have the potential to disrupt. Some of them that I have mentioned here are yet R&D states. Not all of them are commercial except for lithium ion and some varieties of lithium ion. Some of the assumptions that certain developments are challenging because they are unlikely to be achieved through incremental improvement. So we need some breakthrough kind of technology disruption. And that has to happen not only in lithium-ion batteries, but in other forms of batteries also. I will also show you some other kinds of batteries which are being worked upon in different places in the world. The innovations in battery technologies listed above can provide cheaper and safer alternatives for energy storage. Now, battery performance has a couple of metrics, a couple of parameters. One is energy density, the second is power density, the third is cycle life, and fourth is charge rate. I will not repeat what is being shown here on the screen, but for various kinds of applications, starting from electric two-wheeler, three-wheelers, passenger EVs, commercial EVs, stationary storage, consumer electronics, these are the kind of metrics which are important. So somebody who wants to, let's say, focus on a battery type which is important for commercial EVs can actually find what are the things, and he can, one cannot actually, so to say, be able to cater to all kinds of sectors. So people will have to find a niche for themselves, and then they will have to do research, and manufacturing capacity has to be set up specifically targeted to that sector. Am I audible? Is everybody able to hear?
Yes, sir.
Okay.
Yes, sir.
So now, what are the various types of lithium-ion batteries? We all know that anode is typically a carbon graphite, and different types are based on the cathode metal composition. Lithium cobalt oxide, lithium nickel cobalt aluminum oxide. These are names which those people who are in the battery business will know them. Lithium manganese oxide, lithium ferrophosphate, LFP, these are the abbreviations. Lithium nickel manganese cobalt, lithium titanate oxide, etc., etc. So a lot of research is going on in these areas and in other kinds of batteries also. I will just share the names. I am not a battery expert, so I will not get into the technology details. But what is important is, if you combine with the sector that you want to get into and the metrics that are important for them, you can actually choose a particular type of battery where you would like to do research. In advanced lithium-ion batteries, there are lithium sulfur, solid state, lithium air, lithium carbon, semi-solid. Now, all of these batteries, they are heavily dependent upon import of rare minerals like lithium, cobalt, nickel, graphite, manganese, and India is deficient, doesn't have control over the global supply chain. So what is, and besides being an energy security risk, so what is the next step that we as Indians can take? Therefore, we as Indians need to undertake research in advanced cell chemistries where the input material should be what is available abundantly in India, such as sodium ion, aluminum air, liquid metals, and zinc hydride. So there are various types of batteries which are flow batteries, sodium sulfur, sodium ion, zinc air, aluminum air, supercapacitors. And if you want to get a little more details on all of them, you can go through the Niti Aayog report. It also says in which part of the world, which are some of the companies who are undertaking research. Those who are interested can actually get in touch with them. We can also facilitate that if those who are interested, and we can jointly also submit proposals to GUJCOST for undertaking research in these areas, which are important for India. So thank you so much. My purpose was to initiate a discussion and tell all those who have joined today to decide in their mind what kind of batteries they would like to work upon you cannot probably work on all kinds of batteries because every battery has its own specific characteristics on all these things that I've shown here. Choose that, and that particular battery will cater to a specific commercial domain. Some will be able to work in the two-wheeler, three-wheeler sector. Some others will work in the large buses, electric vehicles. So we need to decide, and then we need to develop a proposal which can be submitted to GUJCOST. Thank you, all the participants. Thank you, GUJCOST. Thank you, Dr. Sahu, particularly for inviting me. I just wanted to give a flavor of what is available in the marketplace. We are in our nascent stage, but there is a big opportunity in terms of numbers, in terms of value, as well as in terms of numbers. And therefore, those entrepreneurs who are actually today here should decide. They can contact us in Germany. We will be able to also help them. Our department, which is taking care of new technology management. Thanks a lot.
Thank you so much, sir. In fact, before this is actually one of the very nice and crisp talk actually on, and this is actually what was needed. In fact, the ideas that you gave, the requirements that you highlighted, all these things were actually important whenever the PIs they have to submit a proposal, and if they submit the proposal as per the need of the hour, then of course the chances of the idea selection is good. Someone has raised a hand. Vinit, can you just go in the other room? Someone has raised a hand. I think Krishna
Patel.
Krishna Patel. Would you like to share something, Krishna Patel? You had raised your hand. Okay, so sir, once again, thank you, and I think the PIs have greatly benefited from this talk, and and you have given so many ideas actually, and the door is now open for collaborative proposals for all the PIs who have joined here. You can collaborate with each other, with Jeremy, and submit proposals to GUJCOST as well as look for grants at the national level as well, because this is a very upcoming area where the government is actually pouring the funds. So thank you.
Sir, actually, it's a very enriching, sir, after presentation, giving a very wide scope of energy research work and storage development is going on. I think this is also a very broader perspective. Currently, all the PIs are looking for proposal on that thing.
Yeah, I would want all those who are present here today, let them actually go through the NITI Aayog website, go through a little more details, because there are 3 reports that are available from NITI Aayog. And the second report specifically talks about the technology ones. First report talks about the market size, the opportunities that are available. The second report speaks of the technology, and the third report talks of the government schemes that are available in terms of PLI, in terms of other support, etc. Now, what is important is that everybody cannot probably work on every kind of battery. So therefore, those who want to work, they have to decide what is the area they would like to, because each one has to be a specific subject.
Sir.
So the zinc air battery will be different from the solid state. Therefore, you can't work together at the solid state as well as zinc air. So you decide on a particular area. We are here. We can collaborate. We can provide the guidance, and we will be able to also join hands with those who want to undertake research in these areas. That's my
I think this is a very this is good input for having that time. That's this thing, defining the area, defining the also a little bit scope and collaborating approach also. Suppose but this is the first we have opened the door so that we are getting all the ideas and all the thing, and we will be sharing it with you also.
There is huge opportunity, Dr.
Because our ultimate goal is that we have to have some sort of good proposal for the state government funding,
right,
as well as the government of India funding.
Yeah.
And incidentally, there is the proposal for energy sector for government of India DLT. That proposal is the window is open for online submission. and the last date is on 7th of June.
Okay.
So that means if you can prepare some good proposal, either individual institution or within collaborative institution, then it would be better that with a online recommendation of the State Council, that you can submit it to the DST Government of India, and it would be having, because it has already have some sort of brainstorming thoughts has already been given. So it would be a very fairer chance to get it approved and get it positive response of the committee members there.
I will talk to my colleagues in Germany and then we will try and submit as far as we can.
Yes, sir. And I will be sharing the link of that DST Government of India as well as their proforma for submission of online proposal, so that it will be helpful for every one,
Sure.
PI to all the institutions, so
Right.
they can send the proposal accordingly.
Thank you.
Thank you. Thank you so much, sir.
So there is one person has raised a hand.
Nagrale sir.
Yeah. I have raised the hand.
Nagrale sir, yes.
Yeah, I'm audible.
Yes,
Yes, sir.
you are audible.
Yeah. Actually, I have some queries to the Dr. Sahu.
Sir,
Yeah. Actually, you told me that no, we are going to submit the proposal to DSP now regarding this battery applications.
okay.
So I could not able to get what actually you told to Dr. Roy. Actually, I'm not able to get that one.
No, Dr. Rai sir has given a very wider perspective of energy sector research and the scope and the area in India, China, and other
Yeah,
developing countries.
That is okay, but regarding the submission of the proposals for that battery applications, which is the DSP has already announced this call, which is last date is 6th June actually.
Yes, sir.
Yeah. So you told to first you have to submit to the GUJCOST and you will forward to the DSP like something you told, no?
No. What I understand
Not forward. It is GUJCOST will be not forward because it is an online submission.
Yeah.
So your proposal can be any PI can submit their proposal directly to the DST as per their online portal within the last date. And after that, GUJCOST can send a recommendation because GUJCOST is a part of that committee and that process because it is a state S&T council.
Okay.
So our role is we have to coordinate with the state government as well as the government of India.
Okay. So shall I if we are submitting the proposal to DSP, before that shall I inform to the GUJCOST or I directly submit to the DSP and GUJCOST
First,
will
you
be
can directly
automatic?
submit a proposal directly to the DST as per their deadline and this thing. Then you can submit a copy of that proposal with a hard copy or email to GUJCOST.
Okay, got it. Okay, thank you. Got it.
So there is one question, sir, from one of our participants, that will topics related to battery thermal management. So
yes, thermal management is also very, very important. For example, flow batteries. Flow batteries require special housing for thermal safety. Now, if somebody wants to work in that area, yes, thermal safety for batteries is an extremely important aspect. And we have had cases of fire taking place sometimes in Hyderabad. You must have read in the newspapers. There have been cases of fires because these batteries are not actually geared to handle the kind of ambient temperatures that we have in this country. So therefore, thermal safety is an extremely important aspect for specific types of batteries. It is in general important, but for some certain specific types of batteries, for example, I just now said flow batteries, it is extremely important. Sodium sulfur batteries, it is extremely important. So this will be an important subject.
thank you, sir. So with no more question as of now, we will move on to our next speaker, Dr. Vishal N. Singh. Dr. Vishal Singh is a professor and principal at A.D. Patel Institute of Technology and C.L. Patel Institute of Studies and Research in Renewable Energy. He has done his BE in Mechanical Engineering, ME and PhD in Thermal Engineering from IIT Delhi. He has more than 22 years of experience and has been associated with Indian Society of Technical Education, Indian Society of Heat and Transfer, Indian Cryogenic Council, National Society of Fluid Mechanics and Fluid Power, Indian Society of Heat, Refrigerating and Air Conditioning, Engineers Society of
Screenshot.
Automotive Engineers India, and many more. Sir, we welcome you and thank you for giving time for this important talk on new avenues in biomass as a renewable energy. Now I open this forum for you. You may please share your presentation and unmute.
Very good morning to all. I am thankful to Dr. Sahu and the GUJCOST team for inviting me and giving me opportunity to be part of this discussion. Thank you, sir. I will be starting with my presentation. This is one of the very important topics that has been of an importance to all of us. Is my presentation visible?
Yes, sir.
See, energy cannot be created and it cannot be destroyed. It can only be transferred. And different forms in which energy can be stored. We have to take advantages of all these forms. Just to give you a glimpse of idea about different storage platforms. If we look at this particular curve, this is a discharge time at rated power and the system power say ratings. There are various options that are currently available from say super say capacitors to say lithium ion say battery, flow say batteries. But then we have possibility of storage for even say larger systems like hydrogen in fuel cells, pumped hydropower storages, compressed air energy storage. When we are looking at say storage solutions, we need to look it in a very wide say basket. EVs they do provide advantages, but then we have to look at the option of green hydrogen. If we look at the Japanese research areas, if you look at the leading say manufacturer like say Toyota, they have gone hybrid. They have not gone the EV way. Even they are say promoting hydrogen based solutions in say, countries like Germany. Already hydrogen green hydrogen based trains are being experimented. So we have to look things from a say 360-degree view and then take calls about the future of various storage technologies. Now to focus on biomass. So biomass, as we all know, we are say, getting it from agricultural waste, forest waste, industry waste, municipal waste. We are say, generating bio waste in say very large quantities. This also becomes a problem to us. So we can find a solution to convert this into some form of energy that can be stored to use at a later stage. So now what forms can it be converted to? So basically energy from various biomass, municipal waste, agricultural waste, they can either be converted to liquid like ethanol, biodiesel, methanol, vegetable oil, pyrolysis oil, or say gaseous forms, biogas, producer gas, now compressed biogas. That is again a thrust area of say government of India, which is being promoted by Prime Minister himself, and in the basic forms like charcoal and torrefied biomass. There are various conversion technologies available. Biochemical route, wherein through say digestion, anaerobic digestion, fermentation. Then there is a thermochemical route, wherein pyrolysis, gasification, combustion, liquefaction technologies are available. Now, in this again, there could be augmented techniques used. That say you can create platforms wherein you have hydrogen enriched fuel that can be created. So we have to produce sustainable solutions. Although the journey has been very long, but still we need to find a more, say, meaningful, sustainable solution that will offer us for the energy needs in time to come. National Bioenergy Program, which is up till 25-26, has given a lot of emphasis, and it is providing a lot of funding for these initiatives. Now, again, International Energy Agency estimates that bioenergy may say produce 130 million ton of oil equivalent, which is a very big amount. It is almost 15% of the total energy demand that we have. So even if we are able to cater between 5 to 10% of the total energy demand through this particular segment, it would be a very big achievement for us. So MNRE has been promoting various solutions for, say, agricultural waste, municipal waste, but again, there are issues with, say, scaling up of these issues. Honorable Prime Minister has shared vision of India's energy future based on accessibility, efficiency, sustainability, and security, wherein compressed biogas production is one of the probable solutions which is being promoted in a very big way. As we know, India is a country which is having very large cattle population. Now, this particular cattle population can be used as an asset also. Now, in the compressed biogas, we will be producing biogas and also providing organic manure, which will help us reduce fertilizer subsidy also. Our, say, biofuel policy is, say, encouraging blending from 10%, 20%. And if we see the example of Brazil, wherein they have gone in for 100% fuel based on biomass and the agricultural produce. If we look at the national policy, Prime Minister inaugurated bio-CNG plant in Indore in 2019. 550 ton of organic municipal waste per day is being used to produce 17,000 kg of bio-CNG and 100 tons of organic compost. Various municipalities across India are being encouraged, are being provided subsidies to take these initiatives forward. And as I told, we are taking advantage of large cattle population in form of Gobar Dhan. Various organizations, including NDDB at, say, Anand, they are taking initiative to, say, spread with the cooperative movement that we have in India, like Amul and, say, other state initiatives. We can make use of all these connections and then multiply this particular factor and take advantages of Gobardhan bio-CNG plants. So 80 to 90% of municipal waste was going to landfills. Now these landfills are being dismantled and are being used to produce biofuels and, say, manure. So we have to keep our, say, society clean. We are seeing the problem of burning of parali, wherein a lot of pollution is getting created, particularly in North India, particularly in Delhi. That causes a lot of smog and is creating a lot of health issues also. We at our institute are, say, working for, say, various technologies like Hello, there was a power cut. Am I visible?
Yes, sir. Yes, sir. You are visible.
There was a power cut between. So we are working on various technologies like uh, fluidized bed gasifiers, plasma gasification of industrial waste. There are other pyrolysis-based technology. There are various gobar gas plants, compressed CNG, compressed biogases are being purchased directly by various oil companies, which will offer us a say long time solution in time to come. Fine. So I will end my discussion here and open the forum for say questions.
Thank you, sir. Thank you so much for your inputs on the renewable energy and the biomass. And it is again one of the uh, important actually areas where the PIs can think of creating storage solutions for renewable energy also. And indeed, I think the PIs must have benefited immensely with your presentation and the talk that you gave right now, with the ideas on how to generate renewable energy as well as giving certain ideas on how to store it. So storage of energy is actually the call of the hour nowadays, and uh, uh, thank you, and maybe after the next session, we can take some discussion amongst the expert and the PIs. So first, yes, there is one question which I would like Akansha to read out. What it is?
May I come in?
Plasma
Yes.
has a
Plasma has it.
limit of higher power, so what to do?
There is some question on plasma related energy which has a higher power.
For say paralysis based solutions, many say plasma based solutions are also being proposed. IPR has also worked on similar platform. So depending on the nature of input that is available, various technologies can be used to provide initial power for say paralysis processes.
Yes. Biswajit sir, you wanted to say something?
Yeah, I actually wanted to communicate with Dr. Vishal Singh.
Yes, sir.
We have been doing some consultancy work with one of the Maharatna oil companies for setting up of their biogas plants in 7 locations in India. We are also working for Gujarat Municipal Corporation, and Ahmedabad Municipal Corporation has also recently got in touch with us.
Yes.
Producing biogas is a fairly, by now a very standard thing, but there are 2 or 3 areas where research work can be undertaken. One, to my mind, and in minds of my colleagues also here has been, when through the digester, when we are producing biogas, the purity is somewhere in the region of 60–70%. But to be able to mix with the uh, biogas, natural gas, we need to have this purity to the level of 92% plus for these statutes. But we would like to collaborate with you and submit a proposal to undertake research work in increasing the purity from this level to 95% plus, or maybe 98–99% plus. If that appeals to you, I will ask my colleague to get in touch with you, and then we can submit jointly. This is an important area as far as
We can explore the possibilities definitely.
yeah. So this is something that we would. This is one. Second, there are various kinds of feedstocks that come to a biogas plant. Mixed may be aata hai, and in the bio portion also, we may have cow dung, we may have vegetable waste, we may have hotel waste, we may have all kinds of things. Now, some pre-treatment has to be done, is normally undertaken, that we have been suggesting to our clients also. Can we
Open and
identify a few enzymes or few bacteria together, a joint project where it will help in quicker digestion, which will release higher amounts of methane, natural gas? So these are 2-3 areas where I think some kind of basic research is required to be undertaken to make this sector. It hasn't yet caught on the way government had thought it will. There are some reasons for it, and the reasons are the purity. So can we work together? That was all that I wanted to tell you.
Sure, we can say definitely explore the possibilities.
Sure. Thank you.
So one of the purpose of getting collaborations is seem to be solved, and
Thank
and
you.
now we will move on to our third speaker, and thereafter we'll have another round of discussion. So we will now move on to Dr. Rajaram Nagrale. He is the principal scientist at CSIR CSMCRI. He served as a Ramanujan Fellow at Department of Science and Technology in India, Senior Research Fellow at CSIR, and he has done postdoc from University of Texas at Austin. He has more than 114 publications as well as many book chapters. He has also been awarded with Professor G.K. Narayana Reddy Gold Medal. His area of interest is ionic, polymeric, and carbon materials for organic redox flow batteries, supercapacitors, tissue and organ regeneration, etc. Electrokinetic insulin pump for diabetes management and infusion devices, proton exchange membranes, and so on. And as CSMCRI, we all know that they are very good at desalination, and several technologies have been developed from CSMCRI. Dr. Nagrale will take us on energy efficient desalination technologies. Sir, over to you, and thank you for, while we share your presentation, I would like to thank you for actually giving us time and your consent for giving such this talk. I hope the PPT is visible to you, sir.
Yeah. Thank you very much, Dr. Puna, and really thankful to Dr. Sahu for inviting me and hold this GUJCOST team. And it is nice to be here and to see the lot of the new minds we are interested in the research. And if you see the new generation India, we should be in the energy efficient or self-reliant. And for that purpose only, the government of India is looking for the energy storage devices, because whenever we go for the renewable energies, solar and this thermal, this wind powers, they always topmost, but they are intermittent in nature. And in order to store the energy, certainly we should go for the battery and other options to store the energy. And if you see the battery generally consists of the three components: electrode, electrolyte, and separator. And CSMCRI is being a pioneer in the membrane science and technology. We are developing a lot of membranes for the different applications. And certainly the separator is one of the area which comes under the interest of the CSMCRI. And we are working on the separators for the battery, separators for the flow battery, solid state battery. For all purpose we are working for that. And also whatever the separator we go for the this functionalization to make the charge membranes, we can go for the desalination also. So everything is interrelated. So here I'm going to talk about the energy efficient desalination technology. And specifically, we can keep in mind this desalination technology, which is for the energy storage applications. Because whenever we think about the desalination, always we think about the drinking water. But here it is something different. So certainly we discuss about the drinking water also. So if you see the next slide, please. Next slide. Hi Poonam, can you change the slide? Yeah. So if you see the water distribution in the world, about 70% water is in the ocean, which is the saline water. And out of that, just the 1% water is accessible to the other purpose. And because of to get the good quality of the water to everyone, we should rely on the desalination. And the different types of desalination techniques are there. And depending on this type of water, we should choose the desalination technologies. And if you see the water distribution in the India, the Gujarat places in the very scarcity of the water region. And because of that reason also we should look for the desalination technologies. Next slide, please. And see, these are different types of desalination technologies. So depending on the feed water characteristics, water demand and capacity, energy availability and cost, environmental impact, cost consideration, and technology performance and reliability. Depending on these parameters, we should choose the technology for the specific applications or specific regions. And if you see the different types of waters, if you say about the distilled water, it is having the conductivity about 1 to 10 microsiemens per centimeter, and fresh water about 300 to 800 microsiemens per centimeter. And this is usually drinking water. It is generally used for the all the purposes. And even though this water is also used for the energy storage applications, where we can make this as a distilled water and we can go for the electrolysis, impermeable electrolyzer or alkaline electrolyzer, and we can generate the hydrogen from the renewable energy and we can store. So that is the purpose where the water is plays a very important role, as well as the desalination plays. And apart from that, natural water, sea water, and brine water. Next slide, please. So CSMCRI is very pioneer in this type of desalination technologies. We are having the technology for the hollow fiber-based membranes for the desalination of the brackish water or seawater. We are having the well-established technology for the reverse osmosis as well as the electrolysis. And recently, we are actually working on this forward osmosis and membrane installations. Generally, the reverse osmosis and electrolysis, these are the two technologies we are dominating in the desalination area, where the reverse osmosis is always in the topmost positions because of its energy efficiency and wide applicability of the different types of water. And if you see the electrolysis is also equally important, but the energy consumption compared to the reverse osmosis is little bit higher. So, but they are the complement to each other. So next slide, please. So if you see the difference between these reverse osmosis and electrolysis applications, the advantages of the reverse osmosis, it is a comprehensive. It can remove everything from the water, even though organic molecules also it can remove, and it is having a very high efficiency in the large scale. Suppose for the large scale applications, if you are looking for desalination technology, always you should go for the reverse osmosis. And it can work with the high TDS input, means even the brine water also it can work. And advantages of the electrolysis is high recovery ratio, means the water recovery is very high in electrolysis compared to the reverse osmosis. If water recovery is say about in the reverse osmosis about the maximum 30% water recovery you can do it, but whereas in the electrolysis up to 70 or 80% water recovery we can do it. And it is we require very low pre-treatment in the electrolysis. But disadvantage of the electrolysis is low salt removal ratio in a one stage, because we are removing salt from the water. So that is the reason there is a low salt removal ratio, and it cannot remove the organic molecules. If any organic molecules are present into the water, drinking water, it cannot be removed because it is simply works on the principles of the electric gradient. And generally it is having the high power consumption, and the higher output TDS, because the water recovery ratio is high. Certainly the whatever the concentrate is there, it has having the very high TDS. And if you see the disadvantages of the RO membranes, it is complicated pre-treatment. You are necessary very high pre-treatment here, and it is a very high pressure system. And because of high pressure system, you need the noise, high maintenance cost, low recovery ratio, and membrane fouling. Membrane fouling is a serious concern in the reverse osmosis. And if you see the range of TDS where it is effective, in case of the RO, 50 milligrams per liter to 46 milligrams per liter, it is very effective. Whereas in case of AD, it is 200 milligrams per liter to 3000 milligrams per liter. In this range only it is very effective. So generally reverse osmosis is used for the seawater or brackish water desalination, and for the production of the pure water, ultra pure water. Whereas in ED, Brackish water or small scale seawater desalination, it is generally used, mostly it is used for the wastewater processing, food processing, and the salt concentration. Next, please. So, if you go for the different types of water, because whenever you go for the energy storage applications, the different types of waters are there which can be used for as a feed for this electrolyzer to generate the hydrogen. So there are different types of water, say for the type 1, type 2, type 3, and type 4. It depends on their conductivity and presence of the salt. So generally type 1 water is a highly pure water. It is called the ultra pure water, and it is having the resistivity of 18 mega ohm and conductivity about 0.6 microsiemens per centimeter. And it's having total carbon is about less than 50 ppb. And generally this type of water is used for the HPLC as a mobile phase, GC, AS, ICP-MS, all types of sensitive analytical techniques generally it has been used. And even though it can be used for the mammalian cell culture, and even it can be used as a feed for the PEM electrolyzer, generally this type of water. And second type of water is, it is the standard, it is the type 2 water, where the resistivity is about less than 1 mega ohm per centimeter, and it is used for the general clinical purposes and washing the machines and standard autoclaves. This type of purpose they are used. And generally it is when used for the reverse osmosis followed by the electrodeionization or passing to the ionization resins. And type 4, it is having the general purpose for the non-clinical applications. Generally it has been made for the reverse osmosis. And type 4 is used for the general distilled water, and generally it is a feed for the all these type 1, type 2, or type 3 type of water. So next slide, please. So generally the ultra pure water usually made by the electrodialysis. So most of the people may not be aware of what is the electrolysis. The electrolysis is a technique where when you apply the electric gradient across the membranes, it can separate the ions. But depending on the salt concentration and arrangement of the membranes, the extent of salt removal we can tune by applying the electric gradient as well as the feed concentration. So generally it is cell pair, usually having the cation action membranes and anion action membranes. And whenever you are applying the current, usually cations usually pass through the anion towards the anode, towards the cathode, and anion usually pass through the anion action membranes towards the anode. So alternatively, one compartment will be depleted with the ions, and one compartment will be the concentrated. And this way, it can do the desalination. But one of the beauties, you can tune the concentration of this depleted compartment by applying the current. So next slide, please. So using this technology, we are having the next slide, please. Can you go for the next slide? Okay. For this purpose, usually we should use the membranes. So usually this one is the cation action membranes and anion action membranes, and CSMCR is having the very good expertise on making these membranes in the large scale. And generally it has been meant for the copolymerization of styrene divinyl benzene followed by the sulfonation or quaternation to make the anion and cation action membranes. After making, we should go for the thorough characterization. So next slide, please. So this is the detailed electrochemical and physical chemical properties of whatever the membranes we are developed at the CSMCRI, and they are having the excellent electrochemical properties, and they are the best comparable to the best available membranes like NEFN 117 or Neosupta membranes commercially available. And these membranes we are using for the desalination purpose for the large scale. Next slide, please. So this is the one of the typical electrolysis unit we are having. So it is having the membrane size about 82 into 42 centimeter. It is around 3,500 square centimeter area, one single membrane. So usually it is around having the 100 cell pairs, and we generally apply the 1.5 volt per cell pair. So within this electrolysis unit, we can get about 400 LPH water for 400 LPH as the product water, and the water flows 400 LPH, and product water TDS about 500 ppm. It is a drinking water. and concentrated water flow is about 68 LPH, and water recovery is about 85.7%, and its energy consumption is about 4.3 kilowatt hour per cubic meter of water. And this is the images of the surprise, means these gaskets we are using. This is specially designed gasket at the CSMCRI, and we are having the good expertise on this area. Next slide, please. Yeah, depending on the salt concentration, the energy consumption is varied. So if you see the table here, if you are having the feed concentration is about 6,000 milligrams per liter, energy efficiency is about 80%. And energy consumption is about 4.3 kilowatt hour per kg of salt remover. And if it is go for the 9,000 milligrams per liter, it is about 3.96, whereas in 12,000 milligrams per liter, it is about 3.19 grams. This clearly indicates as the salt concentration increases, certainly the energy consumption is also increases. But this is one of the best technology. Go for the next slide. Yeah, and this we are having the some societal mission also. We are installing some of the villages for the drinking purpose, and these are some photographs. Yes, next slide, please. Yeah. So one of the beauty of this electrolysis dialysis. So if you go for this reverse osmosis for the drinking water, it removes everything. Maximum reverse osmosis, the output water ppm is 50 ppm, and generally the doctor generally doesn't prescribe this type of low ppm solution for the drinking purpose. So in order to get the mineral balanced water, if you go for the market and if you brought the drinking water, it is a mineral balanced water. Generally, what they will do, they will go for this raw water, followed by the sediment filtration activated with the carbon, then RO. They are removing everything. But in order to balance the TDS, so generally the TDS for the drinking water is about 200 ppm. So they remove some of this bypass this feed water, pass through the UL, and they just balance the TDS, followed by the UV treatment, and go for the product water. So this is the general procedure. But instead of this, if you use the electrolysis this technology, because the membranes which are having the very ion selective, they are generally selective for the monovalent ions. So they don't remove the minerals like the magnesium, calcium, some micro elements. They are not going to remove. Because of that reason, mineral balanced water we can make by using this membrane, this electrolysis technology. So go for the next slide, please. Yeah. So this is the one of the unit we are having at the domestic units, where we are the feed water is about 3,000 to 6,000 ppm. Generally, just we go for the microfiltration followed by the ED and the ozonation to get the product water. And if you see the product water quality, this is the in the table. The third column is the drinking water produced by the ED, and if you see the compared with the RO, the TDS about for the ED it is about 458 ppm, whereas in RO also 460. But if you see the magnesium in the RO, there is just 11 ppm, whereas in the ED you can get about the 60 ppm. And sodium in the electrolysis is very less, it is about 85, whereas in the RO the sodium is very high, 199 ppm. Similarly, chloride, and also sulfate and carbonate. So this clearly indicates that by using this electrodialysis technology, we can go for the mineral balanced water. Next slide, please. So another interesting fact about this technology is that we can make the alkaline water. Nowadays, it is very crazy to drink the alkaline water. So generally, whatever the commercially available alkaline water is made by the slightly electrolysis of the water. But using this electrolysis technology, by slightly changing the cell voltage, we can make the alkaline water. Next slide, please. Yeah, this is generally the current voltage curve for the whatever the alkaline water we have made at our laboratory. So using this method techniques, certainly we can, by applying this voltage, certainly we can fine tune the mineral balance as well as the pH of the solutions, and we can make the really good alkaline water which is having the pH about 8.5. Just next year, please. Next slide. Yeah. Another interesting use of this electrolysis is the generation of the ultra pure water. So ultra pure water is the less than 1 ppm TDS, this type of water. So how we can remove that means this such a low TDS water is really challenging, and for that purpose, this is the schematics we have used, where it is having the ion action membranes and cation action membranes separated by the ion action resin, mixed with ion action resin. And when you usually apply the high voltage, generally we are applying about a 25 volts per cell pair. So in such a high voltage, the water gets splitted, and because of splitting of the water, the resin is get self regenerated almost all the salt solution get removed from this method. So if you see the this uniqueness of this water, it is having the type one. This is the type 1 water, where it is having the resistivity of 18 mega ohm, and total POC is about 1 ppb, and pH is about 7, and flow rate about 15 lph. And generally we are using the feed water as the groundwater or municipality water, and it is having very high water recovery. So we are having this is the technology we are having, which is having the energy consumption about 8 to 10 kilowatt hour per cubic meter of water, and its maintenance cost is really negligible. And if you see the cost of the water, is about rupees 500 rupees per cubic meter. And also we are selling this for the academic or some schools or IITs. We are selling this technology and this electrolysis unit. So we are having the facility or capability to build the 100 lph of this type of units we are having. Next, please. And this is actually the benchmarking or quality of the waters which we are generated in comparison with the molecule waters. Generally, people are using this molecule water for this type of applications. So we have compared the data, and we found this whatever the data produced by the electrodeionization in our laboratory is the best matches with the molecule water. Next, please. And this is the certainly design of this electrodeionization stack, and this is the unit. So it is a series cum parallel flow pattern and parallel counter flow arrangement, optimizes spacer thickness and minimum spacing between the membranes, and improve the flow turbulence. So this is the actually images of the spacers, gaskets, and about 15 lph this EDI unit. Next slide, please. And certainly the whatever the ED we can use for this wastewater treatment also, and this is the one typical example where we are used for the concentration of the waste. Waste is also generated in as a effluent in a lot of industries. So in order to concentrate that waste, we can use this ED technology, and it's highly energy efficient energy technology, where we are having about this unit. Usually we are using 0.5 molar NaOH, and we can build about 1.5 molar solution. We can able to concentrate about 3 to 7 times concentration we can build up, and rate of NaOH recovery is about 0.7 kg per hour, and the energy consumption is about 2.2 kilowatt hour per kg of the NaOH. And this is the one of the best technology we are having. Next slide. So in general, electrolysis is emerging as a proficient desalination technology, particularly for the valuable for generating ultra pure water of different types. And its versatility extends to the various applications, including the wastewater management, where it proves highly effective. Thank you. And I can welcome for any doubt or questions from. Thank you. Yeah, there are a couple of questions are there. Some Rahul.
Yeah, Rajaram.
Yeah.
Yes, I am from the Germany. I am the research associate and working here since last 10 years.
Oh,
We have like a very good expertise in graphene-based material, particularly graphene oxide.
okay.
So this is this is a like a wonder material.
Uh-huh.
So we have like a joint venture or like a joint research proposal on the purification of the water or any of the supercapacitor?
Certainly we can think about, no problem.
Yeah, we can have the further discussion.
Yeah,
Uh,
yeah.
I will drop my email address, and Even Biswajit Roy sir is also no.
Yeah, yeah.
So we can have some joint proposal, or we can have some further discussion regarding the graphene-based supercapacitor as well as the purification of the water,
Yeah,
because
yeah.
graphene is also like a very good role for the purification of the water without using any of the power.
Oh, okay. So you are having capacity of making in large scale, or it is in a lab
No, no,
scale?
no. This is on the like research scale only. We have
Okay.
just grant file a patent also.
Okay.
One patent is already approved, which is on the paper battery,
Okay.
and we have also included the graphene oxide with the cellulose material. But we are also interested for the purification of the water.
Okay.
So I know some of the tactics which can be used with the graphene.
Okay. No problem. Thank you. We will discuss.
Yeah.
Yeah.
Okay.
Yeah. Yeah. Sorry. Yeah.
Okay. Thank you, sir.
Yeah.
Thank you, sir. Thank you so much for giving insights on the desalination works going on in the CSMCRI. Before I ask for questions, I would like to request all our PIs to now switch on their videos so we can have a feel of an actual meeting, not a virtual meeting, and then we can have some time to interact.
थोड़ा सा
It's actually really nice to see so many prospective PIs on the same platform, and I hope that you all must have actually benefited. And if you would like to share anything, please do raise your hand. We'll allow you to unmute, and then you can share your thoughts on this session. Any scope you would like to have sometimes later, that also you can share. Yes, Dr. Rahul Kapadia.
Huh. Yeah, good afternoon. This is Dr. Rashid. I'm just with Mr. Rahul Kapadia. Madam, my doubt, like already we have been also got some grant funding before from GUJCOST. So now, as we see that the latest policy, like it has been written that anything related to biotechnology, we need to submit to the GSBTM. So, like what we feel that is we are working on various domains of the biogas, like biogas purification, and also there is a lot of scope for the green hydrogen using the bacteria and all. So these are some of the concepts we want to apply to the Guj Coast. So in this regard, is it possible to apply the projects to Guj Coast or GSBTM? There are many things like we are working on the field application. Like one of the things that is we have developed the first of its kind. This is zero CO2 emission biogas plant in India. Like it means that uh, if you see that the biogas composition, it has the impurity of 40% of carbon dioxide, which we have removed with the scrubbing unit, and that the scrubbed water have been fed to the algal digestive system, algal ponds. So by this we have done many things. We need to like have the submit some projects with, and also tie up with some good institutions and to submit the projects in a pilot scale. Already we have been working since last many years on the biogas concept. So yes, please, thank you.
Yes, we will be coming up with our policy, and the energy storage solutions will, of course, be part of it, as our advisor sir has already said. And in that, if the project fits it, we'll surely take it further.
Dr. Kapadia sir, actually the distinction is that we have a dedicated biotechnology department.
Okay.
So the project which will be dealing with a hardcore biotechnology process and methodology. So the biotechnology department also having the funding opportunity for the biotechnology related projects. Suppose they have any project related to any biotechnology process or product or something like that methodology, then we encourage that this proposal has to be sent to the biotechnology department directly, so that it would be easier for them to identify and select the proposal for the funding. Otherwise, here we are finding it, except biotechnology, GUJCOST will be taking care of all the science, engineering. Okay, and suppose if our technical committee member, they find that some biotechnology processes and this thing is there, so then they also refer it to the GSBTM or a biotechnology department for the funding. So before framing your proposal, you see that if it is a biotechnology process minus, मतलब it has not that much of biotechnology process and the methodology or आपका experimentation or this culture, and it is dealing with the general science terms and terminology, then you are welcome to submit your proposal to GUJCOST. Otherwise, there is no such a distinction, as we have the dedicated biotechnology policy, and that is also their mandate. So we encourage, that is the policy disclaimer, it has been written that all biotechnology related products are to be submitted to GSBTM.
There is one more question, sir.
Sure.
Regarding your STI policy, your fund is last time around 50 lakhs. So there is a same limit for the funding, or it would be increased if the proposal would be higher. I mean, proposal cost would be higher.
No, I think funding would be the upper limit would be same, that is 50 lakh.
Okay, because there is like
and if your proposal is deserve much more funding, then we have other funding systems also.
okay.
We can refer it to the industry department, where you can get more money than 50 lakh.
Okay, so it can be possible.
Ah.
Okay, then it's fine.
Thank you, sir.
Thank you, sir.
Sure. Thank you.
Yes, Dr. Rajat Saxena.
A very good afternoon to all. I am Dr. Rajat from PDEU. So I just have one question. If we can apply related to projects for storage applications, like here, wonderful presentation was given from Jeremy Professional about storage, batteries and other things. I personally work on storage applications, such as we can talk about thermal management, enhancing the efficiency of maybe PV panels, right, and other storage applications. So can we also submit proposals for that under this scheme?
Yeah, actually, the current scheme for our GUJCOST scheme, you will have to wait a little while.
Okay.
The national scheme that is on, you can go on that link and check it out. It is basically development of technologies for energy storage, giving some solution to energy storage. So
Okay.
there are two things. One is the chemistry of the storage
Batteries.
cells. Yes, and one is providing solutions. So, and they have a good limit of 3 crores also. So you can go ahead on that link and share, submit there also.
Okay. Thank you very much.
Dr. Kantha Devi, no, not able to read it properly. Yes, ma'am, you are muted, ma'am. First unmute yourself.
Good afternoon, madam. I'm Dr. Kantha from Harvard University, and thank you for giving the opportunity for many of our scholars who attended the Knowledge One, which you have conducted 2-3 months back. Here now we are also trying to encourage our scholars to concentrate on biogas preparation from the food waste from our hostel, as well as some of them are working on the renewable energy. And two aspects is on the mainly they are also concentrating on the nanomaterials for solar energy production. And I would like to know, is it possible that they can apply for funding with your collaboration?
Exactly, I did not get your question, but as far as I understand, you want to submit proposal to the national level, is it?
Two of them, two concepts. One is for solar energy or renewable energy, and another one is on biogas especially.
Yes, those proposal can be submitted individually, or you can collaborate with the PIs that are here. You can collaborate with the our experts institutes also, and those proposals for the GOI have to be submitted independently. But of course, if you can just give that information to GUJCOST, as a council, we can expedite the process, or maybe tell the government that okay, these are the projects that are coming up.
Do you have any time limit, madam, for Kuch Coast?
For GUJCOST, the scheme is yet not on the floor right now. So you have to wait for some time. As soon as our policy is out, we'll come out with the schemes. So you just keep tracking our website and follow us, and you'll get to know. But you have to wait for the schemes of GUJCOST as of now.
Thank you, madam.
I see.
Anyone else?
Patel, RSC Bhuj.
Yes, someone from RSC Bhuj, yes. Dr. Rajendra Patel, is there someone there who wants to ask a question?
Am I
We are
audible?
not. Yes, yes.
There was one question that the sir told, no, there is one policy by government regarding establishment of biomass plant.
Yes,
So
I think this is a question for Dr. Vishal.
yes,
Yes.
sir, you told, no, that biomass plant government is giving, means there is one policy for that.
Yeah, see,
Establishment.
that is a commercial policy wherein a part of the project, maybe 25%, 35%, based on the capacity of the project, that is being granted by the government to the commercial producers, provided that they have done the sale agreement with the oil companies. So this is a commercial subsidy provided by the government. Right?
Okay, means any community if need to do that, then it is not, it cannot be done.
No, provided you are able to get an agreement with the oil producing company who will be eventually selling the bio CNG, or say compressed biogas, then you will be eligible.
Okay, thank you, sir.
Yes, next we can ask Dr. Kumar Gaurav.
Greetings, ma'am. Actually, I'm from the Department of Science and Science Technology Society here at uh, Central Institute of Gujarat in Gandhinagar. So my question is like we are particularly looking at the issues from the STS perspective. Let's say, for example, in the case of biogas generation, for the scientist, the major question is like how to separate the lignin, like how to introduce the GMOs, and whether we could use synthetic biology, something like that. But at the same time, these technical aspects have their own socio-economic and political ethical challenges. So we look these technology in from that perspective. And is Coast planning to call for such proposals? I mean, from STS perspective, that was my question. Thank you.
Yes, first I will request the biomass part to be a little bit elaborated by our expert. Yes, sir.
What is your exact query, if you can be specific?
Yeah, so sir, particularly we are studying the same technology through STS perspective, where the idea is like it's a social sciences component we apply to these technologies. So my point is like whether so some sort of collaborations could be possible in these two channels. Because you
Definitely.
are
Please share my details with the say participants, and we would definitely like to collaborate with say anyone who is interested.
Okay, sir.
all right, sir. Thank you.
Sure. And again, as I said earlier, also for which course the details you will have to keep some patience. But still, if you have some very good idea, you can you can go ahead with the national level schemes that are currently open. So, if there is no other question, we would like to thank our experts, and I would like sir to conclude this session.
So thank you. It's a good beginning, and I think a good discussion, good networking that has been started since 1.5 hour of presentation. I think it would be a good thing, and we will initiate one topic every week uh, in a very meaningful manner. So that connect each other, institutions, profiles, as well as the strength and opportunities, and accordingly it can be prepared for both state governments, GUJCOST grant as well as the DST Government of India grant. So thank you so much, Dr. Biswajit Rai sir, Dr. Vishal Singh sir, and Dr. Ajaram Nagarala sir, and we'll be in touch with you and we'll seek your guidance for having good proposal for the good development, because one way the government is bringing so many industries, so many opportunities, and other way our research institutions or academic institutions are not getting that type of right communication or message. So to avoid that mismatch and to avoid that type of time delay or that diselections or something like that. So let GUJCOST coordinate and make that bridge between the PIEs as well as the trust point as well as the funding agencies and experts members also, so that we can have a preliminary round of discussions and preparation for our problem statement activity. Thank you so much. And once we'll be through in our approval process of STI policy, we'll be let you know. And in between, I just request that you please go ahead with your proposal as per the discussion. We can share also the details of our expert member to you. Our team will discuss with you. But as the last date of this DST Government of India proposal is about 7th June, so I request that you can prepare your proposals and submit it in time. Thank you. Thank you so much. And all the best for your research job. Thank you.
Thank you all.
So, namaskar.
Thank you.
Well,